Welcome to Playing With Inference, a podcast on the intersection of AI and games. Today, we're going to be talking about AI-powered QA, or maybe agentic QA.
And to do that, we're talking to Jan Schnyder, co-founder of and CEO of Nunu AI, building AI agents to build and test games. Prior to Nunu, Jan dropped out of ETH Zurich to start Nunu. Jan, how's it going?
Going well, thanks for asking. Back in Europe from Tech Week, so still a bit jet lagged. Getting there, getting used to it.
Nowadays, you spend, and this is totally tangent, starting with a tangent, you spend a lot of time back and forth between San Francisco and Zurich.
Yeah, we spend time on SF side and also LA, California in general, to get tapped into the AI space and also games, obviously. But we're still based in Switzerland because we have a lot of good deep tech talent here and are working on AI agents in our office from Europe mostly.
So this is total. I'm just hijacking the whole thing. But I think one of the things that's pretty apparent the first time I heard from you guys was I have this conception of ETH being a very robotics, centered or very strong STEM institution. And when you guys were doing speedrun, I think you did this demo with a Bots and Dynamics dog that had nothing to do with games. And then when you've talked to me, you've often mentioned how you have access to this strong pool of talent in Zurich that goes a long way when compared to what you can get in the US. I wanted to hear a little bit of that perspective of how it is you're essentially building a business in the US with engineering from Europe, right? It sounds to me.
Yeah. It's no coincidence that ETH performs really well at robotics because it's very closely correlated to what we're doing. Funny enough, the initial research that we took that inspired us to do Nunu actually came from a robotics angle. It came from NVIDIA. And we are essentially applying this research with our own spin to the game sector, right? So what we're essentially building is an AI agent that can play and test games like humans would, right? They look at the screen mostly and press keyboard and mouse buttons, or can tap on phone screens. So yeah, our bet was essentially to just get our friends and colleagues from ETH Zurich and build a very strong research team to be able to tackle one of the hardest problems in AI, which is games, just like the DeepMind playbook or OpenAI back in the days.
Yeah, I've had a couple conversations with folks about this, and usually I've been hesitant to push the analogy too far or push the connection too far, but I do feel like, so if we look at AI and agents in the marketplace right now, right, and drawing some very broad brushes, you have a lot of enterprise stuff that's around productivity and building AI agent workflows that replicate business processes and stuff like that. And when I look at the type of AI that I build for video games, to be honest, there are times when I feel more connection to people doing AI, embodied AI in robotics than I do feeling that my problems are similar to the problems people doing enterprise agentic workflows. Now, I'm not trying to say I'm doing exactly, because I can cheat. In games, I cheat all the time. Yes. In ways that I can't cheat in robotics, but I still feel like there's some problems that I find more resonance with when I'm talking to people at DeepMind or other robotics places than I do when I'm talking to the folks who are I'm going to replace my accounting or payroll or this other kind of process with AI or this customer support thing.
Yeah, it makes sense, right? The cool thing is, or why researchers love games is because the environments are just immensely complex, right? If you look at an accounting software and if you look at the latest AAA game, the complexity of the action space, the possibilities that you can have in this environment is just massive, right? And what you said is actually also thinking behind why we're doing games is because in the end, you can cheat, right? It's an abstraction. Picking up an item in real life requires a very complex manipulation policy that is exactly tailored to the hardware currently. It's really hard to do this generalizably, but picking up an item in the game is pressing a button, right? Which is essentially allows us to use games as a proxy to something like very powerful, right? So games already give us the open-ended environments where we can have our AI agents perform actions, test environments, stuff like this. But it's very
is what you're saying. So you're talking about the manipulation and the higher level of abstraction in games. In robotic terms, you are much more concerned on the task planning part of the problem versus the motion planning part of the problem.
Yeah, exactly. We do like high-level planning, not like locomotion or control.
I think that's the point in the game side is you get to pick what your problems are. So you can be like, you could do a perception-based problem in games, right? Because you could simulate visual perception. You can simulate the physics. Granted, again, I do not want to claim that I have exactly the same problems as in the real world because I get to cheat all the time. But you can also choose which set of problems you're going to, and you can make it, you can abstract away and be like, look, we're not going to deal with locomotion because we're going to use a different type of simulation for that in the games. It's a lot easier. Or we're not going to deal with perception in this same way because I know what's in the game world and I can cheat because I know what all the game objects are in the world, right? But by doing that, I think one of the reasons it's interesting is because then I can localize and focus which particular problem I'm solving. Whereas like in robotics, you have to solve to be able to achieve some things, you have to solve all the problems. You can't just be like, I'm going to work through locomotion, but I'm not going to deal with perception. You're going to have a hard time with walls. They're they're just, you get all the problems all the time, including just literally the hardware and like how well the hardware is functioning. And when some particular piece of hardware just has physical problems with it, whereas I get an idealized state in games. But I still, despite that, often feel more resonance when I'm talking with colleagues in the space of whether sometimes it's also just like latency problems and real-time problems that I have in games. Again, I can cheat a little on those, but I have them more.
Pause games, you cannot pause real life, right? So it's a bit of an easier environment.
Somewhere I read, probably Hacker News, that the similarity is not only in the type of problems that you're solving, because, for example, all of these pathfinding are the typical things that you find in games and typical things that you find in robotics, but also in that both games and robotics attract people that just do it because of the love of it. So the salaries that they command are lower versus going B2B SaaS for accounting.
Yeah, it's a curse and a blessing of the game.
Yeah, exactly.
Right. That's like, we're also in it. Passion plays a big factor, right? Like I used to be top 500 Overwatch and top player in Destiny. And we have a lot of people in our team who were like pretty good at video games and now try to funnel that passion/obsession into Nunu. But yeah.
And I'm going to cheat a little based on something we said before we started the podcast. So with Nunu, then, what you clearly are making is a competitor to DeepMind. Right? Is that what I heard? That's basically what I just heard.
Vision, right? Yeah. Honestly, it's for sure an inspiration, right? I think first and foremost, what we currently want to do with Nunu is we want to be the first ones to solve game QA, right? So notoriously, testing games has been a pain in the butt. Not sure if like how much vulgarity I'm allowed to say here, but we want to tackle this problem. We want to tackle this hard problem. It's not easy, right? You don't only need to be able to play the game. You need to be able to differentiate between like intended and unintended behavior as well. But solving this problem will allow us to go broader than just game QA, is what I'm saying, right?
So there's two questions here. One is, how much of the QA is it trying to find bugs and issues, and how much of it is trying to find what is fun and what is working the way that would delight the players? And then the converse of that is, how much of what you're learning from a research side is it about how do you control agents in 3D environments? And the other part is, how much are we learning about what people like to play?
Yeah. So it's funny because we mostly focus on the first part, right? Because the first part still hasn't been solved yet. And this is usually what's much more measurable. But through the approach that we're taking, which is mostly using multimodal models, our tool also allows you to get like very like deep insights into the agent's mind. Every single action that the AI takes is annotated with the agent's thoughts, right? So you can see exactly why the agent is doing what it's doing, what it's thinking. And a lot of our customers are actually fan of this data. I personally wouldn't trust it yet, but this is a direction I think that will come in the future once these models are able to emulate human behavior quite well. Because at this point, you're going to be able to personify testers even, right? You're going to be able to tell the agent, hey, can you act like an 18-year-old boy that's into speedrunning versus maybe a 40-year-old mother that plays games occasionally on a Sunday. Then according to that, the behavior will differ, maybe the paths will differ, the experience is obviously different.
Man, there are so many things that I want to talk about here, but let's talk about this role of QA in general, right? And taking a step on that, because I think that, because I want to get into the intended behavior part, definitely, a few other things, but the role of QA. So I think, so I have never been a game QA. I have worked with amazing game QA over the years, and it is well known to be a challenging role in many ways, right? Like they're often overworked, underpaid. It can sometimes be it is an interesting entry level role. It's one of the few areas in the game industry that is friendlier to entry level, but people like, oh, I get paid to play games. No, you get paid to run against this wall over and over again. So I say all of that because there are absolutely, and I'm all my game QA people who later will hit me up late, I'm curious to see if you disagree, but there are parts of the game QA role that I think many folks would not be too upset to have automated, because it can be very repeatable processes that are, to be honest, not necessarily enjoyable by anyone. But there are benefits in an organization that I get by having QA that go above and beyond you found my bugs. And Ramon hinted to that. I'll give the best QA teams that I've worked with. And when I'm working with a team, this is where I like to put them, is usually like they're the strongest advocate for the player on the team. Because even the game designers, and again, no offense to all my game designer friends, like the QA sometimes is sitting and knows the real experience of the game better than anyone else. The game designer knows what it should be. Yeah. And there's a delta between what it should be and what it is. And the QA on the team often has the best perspective of this is what the game is right now. And the best QA that I've worked with at Riot, at Singularity 6, at so many other teams tend to be strong advocates of what the game should be. And that tends to surface then in two areas. One is in team discussions, in team planning, advocating for where the game really is fun, and bringing the team reality to the team. Guys, I hear what you think this game is. Let me tell you what it's really like right now. And that's both in design and also in real life, in live service games, being like, this is the pain. They're the voice of the pain of the player. The other is that I have used them as a gatekeeper for releases, which is always controversial, right? Because you have to decide who is the person that gets to say this patch, this release goes out, because no release is ever perfect, right? There are security concerns almost always. There are game quality concerns. And so having QA have a seat at the table who can advocate to be like, look, it's got this many bugs. Now, maybe the QA doesn't get to decide the go, no go, but having a seat at the table to be like, just so you know, we've introduced these new bugs or anything else is really important. And I'm sure that you've heard from customers or others around this. So I'm wondering, when you're sitting with, if you're trying to pitch me to be like, and this is why you should replace all of that with AI, like, how does it replace these other aspects? Do you see them still being, do you see them being actually replaced by AI? Do you see that, no, it changes QA to be better at this role? What's your answer to that question?
Yeah, the short answer is it's not going to get replaced, at least for a long time. The thing is, by the time AI will be able to play any game, zero shot, and do the entire QA, this for me personally is like borderline AGI, right? It's an agent able to navigate and act in any 3D environment, whether it's virtual or not. Like the sim to real gap is arguably large or small, but at this point you have something so immensely powerful that 99% of the AI applications are going to get solved before this level reaches, right? So this is also why we're currently like being able to probably automate 20 to 30% of QA. That's the number I currently have in my mind. It's steadily going up, but we're mostly focusing on the part that you said people also don't like doing, which is regression tests, smoke tests, UI tests, like the basic stuff that just needs to be done, that needs to be done properly, which is also an advocate for AI does the job with 100% attention every time. But we think, or what we see essentially just it's the job of the QA person that's transforming. Instead of having a lot of people hopping over the wall 100 times and see where it breaks, you now essentially are controlling an army of AI agents that perform these actions for you and report back. So I'm always doing the analogy to like the Toy Story monkey that's 10 cameras and overseeing all these screens. Like this is for me the job of a tester now, where you essentially have an army of these AI testers that you control and you orchestrate, right? And then report back to you. And you as a tester, first of all, can focus on the more fun aspect, because I think games are some of the very last products that are really only going to be for humans. Yeah. I don't think there's a big incentive to make AI for games, whereas maybe now we do browsers for AI, now we do payments for AI. A lot of that stuff will get away.
When I'm starting to, as a game developer, making games where my consumers are other AI agents will be an interesting pivot in my career. Yes.
Yes. And
you got to keep the AI happy or they'll stop cooperating. No, we got to make games for them.
Because games are inherently for humans, I think it will make always sense to have humans at least have the final word on, is this good or not?
Yeah, so the QA person or team is the proxy for the players, and you need a human to play that role. I just want to note that you opened with, we are solving QA first, and then you followed some minutes later with, if you solve QA, that's AGI. So just
again, it's a hard problem. Yeah. It's a really hard problem, right? And it's a problem that we chose to try to do. And it's a problem with multiple stages, right? Games are like very broad, right? And if you look at from mobile casual games, which we already can do really well and get good coverage, to like more AAA, like very fast-paced, very complex games, there's levels to this, obviously. And there's a lot of applications that already unlock before the last level is reached. But it's a hard problem for sure. And we want to try and tackle it as best as we can.
I'm curious how it feels if I am a modern QA person managing this fleet of agents trying to jump over walls. How does it feel to orchestrate that? What are the type of affordances or levers that I want to have to interact with these agents? Because it's very different to be there and playing the game and like pushing on the specific sides versus look at it from the aggregate, right? What are the type, what does it even look like or feel like if I'm just orchestrating thousands of these agents?
Yeah. The cool thing is we're trying to make this as asynchronous as possible. So it's more just like you're waking up and you just had 100 agents run everything overnight and you can now just review the results, right? Mm-hmm. It's not like you need to micromanage them, otherwise we fail at our job. The other cool thing is most interactions are through pure natural language, right? So you don't need to be technical. You can set up test cases in natural language. You can give the agent instruction in natural language. And the agent will essentially yield you with a complete recording and a report for every single test that it ran, right? So instead of having to do this manually every day, which takes a lot of time, it's not really scalable, you now as a QA person can focus on the more fun stuff or the more complex stuff and just have all this run in the background asynchronously and just review the results, which is 1% of the time that it takes usually.
To connect the dots for me, at least, the model that I've seen in the past that I have used and seen used is what we would call vendor QA, at least amongst my community, where I'm not going to hire because games traditionally require human testers, right? Even when we consider traditional AI or not traditional automated testing for games, like other types of non-ML related testing, right? Because you would try to do everything you can. We've always often had human testers. And so a model would have been, I have a small QA team on my team. We contract with a larger specialized QA games team that we give them a bunch of test plans. They run those test plans literally overnight or whatever thing is. We get that report regularly. And then my smaller QA team will then review those. And those tests do everything from, it's basically just run these test plans on these devices with these things, click through these things, make sure you Can you change the settings? Do the settings actually change? Does it work on this device? Does it work on that device? And yes, this is a form of outsourcing for those that aren't as familiar with the game industry, but it's very common, and partly because there's so much specialization in QA. Like building a full in-house QA team is a non-trivial task for most studios. And just because of, for example, the hardware requirements, right? If you want to test against a number of all the different consoles and all the different like phones, particularly phones, you want to test against all the different phones and you want to test them on different things. It's a significant investment that many studios, smaller studios, will never make because it's just very expensive to build that for yourself. And so there is a healthy number of companies out there that will do this for particularly smaller studios or larger publishers that may have this as in-house option for the companies that they publish for. Again, for those that have maybe more or less familiar with how the game industry works, this is not an uncommon scenario for at least the last decade or longer, probably a couple decades to be very frank. So what I'm hearing is the threat that you're having, the change that you're having, is that you're competing in some ways, not with my internal QA team if I'm running a studio, but with the vendor QA. And is that fair to say, Jan, that if you would want me to just be like, do I go with vendor QA A or do I go with Nunu? And you want me to be able to say you two I'm putting you in the same bucket. Is that fair that you already would be, or do you want to say we do that and more?
No, I think it's a fair comparison in the terms of that we essentially just want to augment your internal QA team, right? So if you're a studio and you already have a bunch of testers and you're like, like it just keeps piling up, the scope keeps going up, and we're like, okay, we cannot just keep hiring. We either need to look for outsourcing, or you can look at a tool like ours, which essentially augments your team to do like similar things, right? But because in essence, we can perform the same tests more parallelized, faster, with better insights, right? Because you're going to get a lot of data from us that's simply not possible. Imagine you have a outsourced QA studio that records every single thought of the tester, every single action of the tester, and gives you complete recordings, annotations, reports for every single test that you're running. Hundreds of them.
You are generating a lot of data. I don't know if you can answer this question, but like that data is valuable to both you and to the studio.
Yeah, we are not allowed to touch any of that data though.
Okay.
And the cool thing is, or the nice thing, the good thing for us is because our AI agents are zero shot, meaning we don't actually train on any of the games.
Right.
We don't have that much interest in that data anyways. Right?
Training on the games would have pros and cons, right? Like you might be more efficient at it, but you're also not building as generalized.
Exactly. That traditionally what a lot of the first few people that were trying to do the same thing did was start with reinforcement learning. That was the previous state of the art.
Yeah.
And it's just one of the large problems that reinforcement learning has is that you first of all need a massive amount of data to train an AI. And then as soon as the game changes, you need to retrain or adjust. And if you get a new customer with a different game, you cannot simply just take the AI and put it on that game. You have to start from scratch again. And that just doesn't really make sense.
It also tends to find these like shortcuts or hacks to solve whatever it was meant to solve, right? So instead of playing as a human will be prompted to play, it's just gonna find the shortest path or whatever version of that to whatever reward you gave.
Yes, which can be interesting if you want to go for stuff like balancing or like just stuff like this, which we don't do, right? Because our agent is essentially designed to be able to complete the task, but no more, right? Like it's never going to be able to speedrun, or it still needs a long way to go to be able to speedrun a game, but you don't need to do that to be able to test a game, right? You just need to be able to play it accordingly.
So models tend to collapse to the median. And I have several questions around that in the sense of how important is it that you get diversity from your models? Does it matter at all that they all tend to like bias, that they have very clear biases and they'll just do that? And if it matters, are you like trying to steer them away from the most likely path? And then the related to that is, if a game is very out of distribution, does it have problems with that? And that could be valuable in of itself, right? If I'm making a game that has very little resemblance to prior games, maybe that's a signal of you have to dumb it down or make it more similar to other games to ease in the players. But I guess I could wonder, like, how much does being outside of the distribution affect the ability of the agent to do the job?
So the bias is something we didn't really observe yet, because the funny thing about games is they're inherently non-deterministic usually itself. So that's also the reason why you cannot script games that well, right? Because there's random pop-ups, there's random spawns, there's random configurations. I guess you can fix the seed, right? But then that kind of defies the purpose of getting coverage as well. But yeah, like we actually have two separate modes almost, which is one which we call verification, which is where you can define a very clear path for the agent to follow, and it will only follow that path, and we will only test for what is mentioned. And then we also have a mode which is basically the opposite, which is exploratory, right? So you get different results every time, different coverage, different bugs reported, right? And like usually a combination of those is what you want to go for if you're testing a game.
So there are games that I've built, simpler games. This was a long time ago, more like turn-based games, which are easier in this space, where, to your point, like one way to test is you just test the entire space. Like you're like, turn-based is a little easier for this, where you're just like, at this turn, there are X number of possible valid options. We write a thing that just goes through all of them. Now, of course, combinatorics mean that suddenly, very quickly, you're at a number of possible things you need to test, that the compute required and everything else gets a little crazy. But there is a way to kind of test games in this space. Is the advantage of and that is a dumb way to test. Again, the real issue is usually like the compute or time to run all those tests starts to get insane, depending on how many options. But is the advantage of the exploratory that it's like smarter in some way to search that space? And if so, like, how is it smarter?
Yeah, I mean, there's a big difference from running scripts and running our AI agent, is that the AI agent actually tests the game like a human would play it, right? So it looks at the screen and it finds stuff like spelling errors, and it finds stuff like, hey, like this button looks weird and stuff like this, right? So it's a very different kind of testing, right? We're not really trying to replace what you can already script. We're trying to replace what you currently need to do manually, which is very tedious. And I think from that perspective, it's different. And the cool thing is it's smart, right? So like the agent, because it plays the game like a human would, can make its own plan, like to sometimes go into the menus and test stuff like this, or check out the privacy policies, or sometimes it just wants to play the game. You can guide it through natural language of what it should focus on, right? But the entire gist of this is that you essentially have a sense of intelligence that helps you identify bugs, right? Which is needed, because if you just run a script and the script fails, especially in games, 95% of the time it's because the game was updated or something is different, not because it's actually a bug. And with our solution, you have a robust, intelligent bot that can adapt to changes of the game while still being on the lookout of, hey, something looks fishy here.
So let's get to then, you mentioned intent earlier. If we could go back to that just a bit, is explain a bit more what you mean by the intent problem from a design, or is this a bug or not? I'm assuming that it means, is this a bug or not? And so could you explain a little bit of that and why it's hard or not hard? Can't I just have the designers provide something that would make this super, super clear?
You can, right? That's the easiest way to do it, but no one likes doing stuff. So that's the inherent problem of testing, right? Testing is a tough space because it's a necessary evil, right? Like the value we provide, the biggest value is, hey, look, use us and you don't really need to worry or care about testing that much anymore. And if we then come and we're like, hey, can you do this and this for us? We're like, oh God, what is this? So yes, you can do that. Like in the end, I think the thing that we want to build is really just upload your game, receive bugs, and then the rest leave up to us. That's the vision here.
So the follow on there is, so now I want to lead Because if you can understand the intent, the reason I'm getting to is like,
yes,
this generalization problem, and we're going to end up right back in AGI here in just a second. It's okay, because understanding whether something is a bug or not is like arguably a very hard problem.
yes,
right? Because it implies intent. And I'll describe a couple other examples real quickly. Like even like in our case, when we're making what we call like AI directors inside of a game, and there's various type of forms and people reuse this, but like something that's like intuiting real-time player intent in a game. The example I sometimes give is that if a player is wandering around in a village, the question is, are they lost or are they like on patrol? And the narrative response that you would want to have in a game would be very different based on interpreting that player's behavior intent. Now, you can elicit it in various ways. You can basically ask the player or signal it, but sometimes you can or can't. And okay, so that's one thing of like where we look at intent. The other analogy I want to give though is on this intent problem, right? And this is it. Recently, I've been talking to some other folks on the coding side, coding agents, right? And like where they go and how far they go. And there's a little bit of a sentiment I've started to see increasingly of they're good at writing code, but not necessarily great at writing software, meaning delivering products. Because when I hear what you're saying, there's a part of me that's, oh, Jan, this sounds like the kind of pitch I've heard from people where it's the way I'm not replacing your software team, engineering team. Each software engineer ends up having an army of agents that's writing software for them and they're coordinating it. Just similar to how you're saying each QA person has this army of QA. I've heard something similar sometimes of, hey, each software person now, each programmer on my team has an army of software agents. But the reason that we're not replacing the human is because there's some human judgment. There's something there. And it goes to this intent, I think, and sometimes. The way I've been increasingly thinking of it is like the why. The scope of why is very big and trying to figure out what that why is.
You need for testing common sense, basically, which is in the end intelligence. Because the funny thing is, there's also different bugs, right? And I'm not saying we're catching them all. There's easy bugs, which are usually very binary to verify. Like when a button doesn't work and you click it multiple times and nothing happens, we're definitely there where the agent is, like something's wrong there. Like this is a button, it should do something, it does nothing, therefore I'm gonna report that. Spelling mistakes, stuff like this, easy, right? It's usually very binary. But the interesting part comes when there's a lot of the testing, a lot of the bugs are maybe weird or some kind of. We had a scenario where when you would chop down a tree, it would drop iron, and the agent flagged it, right? Because it's, wait a minute, I just chopped down a tree and I got an iron item. That seems fishy, right? So we're there where these kind of bugs are already getting flagged, which is very cool, right? But then I think where it's going to still take a long time is, does the game feel good or does it feel fun?
Yes.
This is insanely. First of all, it's such a weird concept for me that you would use AI for this. I guess what you can do is you can try to emulate certain players, right? Which makes sense for me. But to the point where I would trust an AI to tell me that my game is fun, which is not based on real player data, but based on just pure like synthetic, it will still take a while, in my opinion. Because we have customers that already love this, right? So it's fun. It's very subjective.
I would imagine that if you have a very well studied type of game and that is also very constrained, there are ways you can maybe ask that question to either a more vanilla ML or off the bat model, or even an agent. Like I'm thinking like a casino slot machine seems like known science, right? It's a solved problem. We know what you need to do. Some randomness, some colors. People
because you have a lot of data, right? And then it just becomes data science, right? Like that's
I like that bridge of, are we trying to do like data science, or are we doing, these LLMs are like data science compressed into a binary, right?
Yeah, it depends on who you're asking at this point, but and where this will go. But I think to test games, to test an experience, Yeah, you either need a ton of data where you can model it, and then I think you can predict like stuff like success and stuff like quite.
Churn,
This has already been done. Like this, people are doing this right now for their games. But I think the testing side of it usually is play testing, right? Is the game fun? And this usually is just like you ask a bunch of people to experience the experience, right?
Well, the data, okay, I'm very glad we brought up the data question, because again, I wonder if on this problem of is this a bug or not? And then and then not necessarily next highest, but like we go our way up to is this fun or not? I think there's an analogy there that we can make to other domains, which again is, did you write code that passed the spec I gave you? Versus, is this software package fulfilling its purpose of why we need this software? And one of the reasons that we would, and I was talking to another friend about this, is it's a lot about the measuring risks, for example, right? And I know I'm on a tangent here, but I will come back. It's measuring risks. If, oh, yes, you came up with, for those that are doing coding agents, it's like, yes, you came up with a valid architecture, but it's not weighing the risks of like downtime the way I would, because I'm going to throw this thing away, so I don't really care. So you over-engineered it. But other times, no, I want that extra engineering, right? And these are the reasons that it's built that software, but that software is crappy because you put every single API key embedded in the software. Like, it's hard coded. Don't hard code the API keys. These are, though, all of these are like judgment calls around its fit for purpose. And we often think of that fit for purpose as something about intelligence. But a lot of that intelligence is based on context that the model doesn't have. Market context, why historically we've worked together as a team to get to this point, and we have a need, a customer need, a product need that has all of this context of this moment in time and all the history you've had that I'm not writing up and handing to this LLM. Like, it just does not have this context, or these agents are set of intelligence. So when I think about that, because I've generally been one of the ones where it's, yeah, will they ever be able to get there? And I'm sometimes skeptical that more data will do it. But it's doing it at a micro level. It's making these risk and intelligence questions, to your point of like, why did I get iron from a tree? That implies so many things that it needs to have figured out, that if I just scale that up enough, sometimes you're like, maybe it could, but it's just a lot of lived current context experience of everything, of what's the state of games today, or the set of problems that I'm trying to solve, or the market problems, and why I would make this, why I as a product person am making this, as a producer on a game, I'm making this choice of, do I release this game right now or not? If we go to that point of, can your AI sit at my release table and tell me, should we release or not? It has to have this lived context, which is largely limited maybe by its access to data more than its fundamental. Like, the question, is there an architectural fundamental capability of machine learning models, or is it just, it doesn't have this data, which gets to the AGI question.
Yeah, exactly. I'm not going to give you an answer here, right? Because we don't know, right? A lot of people don't like transformers or LLMs because they think they have inherent shortcomings that still need to be fixed through an architectural change to be able to get there, from like transfer learning to whatever. I think the entire reason why we can do what we're doing right now is because this context is represented in the data, right? If you give our agent any game, let's say Hades, to play, well, Hades, not that we can play it well because Hades is very fast paced, but the agent will recognize, maybe even if the Hades is not in training data, once it gets playing, it will know that it's a roguelike because it knows other roguelike. It will know because it knows other roguelike on how roguelikes work, and therefore it knows how to play it on a basic level. And this is massive, right? Because it has that context of different games. And yes, obviously, while there's various genre and amount of games, I'd say there's almost no game that our agent conceptually couldn't play or understand, right? Like, you would have to go into some non-Euclidean geometry games that are really weird to, I think, get to the limits of what's currently possible.
You mentioned there the fast-paced. How does that play? Like, how does, because there's obviously turn-based, I can see where latency is less important, but then how do you manage or deal with latency in real-time games?
So there's a very clear speed and intelligence trade-off right now in any kind of AI that you see. Right? Do you want it fast? You will get it done. right?
Yeah.
Do you want it smart? You will get it slow. Same with us, right? If you want our smartest agent, it's an agent that is not very fast in performing actions, and therefore will have to either use some help or just focus on games that it can't play with this. If you want something fast, or if you need something fast, you will just not get the most intelligent.
Oh, yeah, go for it, Aaron.
Can't you, if I really wanted to use this and I really wanted to use your tech and I think it's super valuable, couldn't I just hack in what the frame rate, like the tick speed is, to slow it down?
Yeah, like what you can do is you can just pause the entire engine thread, right? Yes, you can do stuff like this.
Once again, where games are better than reality.
Yeah.
That's the exact thing, right? You can manipulate the environment to a point where the shortcomings are not there anymore for the agent to perform, to advance, for us to make better stuff, right? Because there are just in the real world, in robotics, some inherent bottlenecks which you just have to essentially wait until they're solved, right?
Yeah.
And for games, you can do a lot of cheating around that.
On the fast and slow trade-off, sorry, speed and intelligence trade-off. So we in our game, Real-Time Monster, you are making commands. So we really like we benchmarked the shit out of models and providers, and we basically just chose the fastest that had above a certain quality, right? One of the things that we've been wanting to do is have some sort of adversarial setup where it's real time and you get to choose your your model for your monster. The game is real time, so it's like there's this trade-off, like how smart do you want it to be versus how many hertz do you want on the decision making to be, or well, not a hertz, but like how frequent do you want the output to land. And I feel like there's yeah, I don't know where that would land. I think that's a interesting benchmark that I would love to see at some point.
Yeah, like it's if you tell people, it's usually like they want both.
Yeah, of course, but I
you
think
could have a battle, like a battle royale kind of thing.
Yeah.
There have been some models like,
Yeah,
I think, is that your point, Ramon?
It's exactly like you have a bunch of bots fighting. Some are super smart but slow, and the other ones are super sharp, super dumb but very quick. Like maybe the speed is advantageous, or maybe just making the right decision once takes the cake. And I think that's yeah, that's a trade-off that I'm always thinking about. So that's why I'm just bringing it out there.
Yeah, it's something we're also benchmarking, right? And the funny thing is, it again comes down to preference. That was what we noticed, because at the very start, we mostly just gave our customers like the smartest one because we're very proud of this one. Look what it can do. It's so good. And they're like, okay, I want it fast. And we're like, sure, there you go. And then some people were like, okay, this is worse. And some people were like, okay, this is better. So yeah, I think like different games, different players, different preferences.
Yeah.
I want to go to your non-Euclidean games, or more just the kind of games that are hard, because one thing we've been exploring, Ramon and I and others, are like AI native games, like some sort of game where machine learning is part of the gameplay. And there are a lot of ways that can introduce what those mechanics are. I think as an industry, we're still exploring what that means and what those mean. What we're going to discover new mechanics over the next couple of years, or at least that's what I hope. But definitely one thing it opens up is one thing it can open up is the action space, like the number of things a player can do. And in our case, for example, for Jam and T, when we were originally starting up as a team, we got on our way towards building Retail Mage, and we realized we need a full-time playtester that we had not actually planned for, because we're like, oh, we're so small, and this is a small game, maybe we don't need that. Nope, we totally did. And for other games that I've built in the past of that kind of size, maybe we would have needed this, maybe not, but we 100% needed it because of how big the space is to test when suddenly you're able to use natural language as an input. And the number of things you test, so the way I describe it is almost like fractal, right? It's like a fractal space. It's almost infinite because of the variance you have. And then like those combinations of, does one word here or there make a difference in the way the model or that model or the 10 models you want to test, to his point. And suddenly you thought you had a big test space before. So when you're thinking about, you're not necessarily building AI games, but you're in this space of applying AI to games, and surely this is something you've thought of or bumped into. What do you think about that? Do you think that do you think this is going to be a problem uniquely suited for you to solve, or an impossible problem for us to solve, or what?
I think there's a way of framing this question. How do you QA your agents?
Yeah, they can QA themselves, which is funny.
They always pass, surprisingly. Like, I do so well, I deserve a raise.
Okay. We do different stuff, right? What we have internally is a benchmark, right?
Mhm.
And the benchmark is essentially an IQ test, which is hilarious. And you can extrapolate this to like having different levels, right, for the agent to solve, and then
Yep.
see different levels, different agents, different configurations, and then measure different KPIs, right? For example, one level can be you have a room and you have a wall in the middle and then just a red ball behind it. And then the task is to find that red ball, right? And then you can go and drop different agents and configurations into that level and see whether they can do it, how fast they can do it, stuff like this. And then you have hundreds of those levels. And then you get a good sense of which ones are smart, which are fast. So
we do something a little different. Do something similar, but a little different, actually.
Yeah. What do you do?
So we have a thing, and I've talked about it in the podcast before, I think, we call them tea readings, because jam and tea. And now we tend to be more interested in the ones we've done the most of tend to actually be on like higher level planning and even social situations, where the way I've described it more is a theater exercise. So it'd be like, we create a 3D scene with a set of characters. We got Jan's there, Ramon's there, and imagine that as a designer, I give you initial instructions. So, Jan, here's your motivation. You are a unemployed person with this type of thing. And Ramon, you are a boss who, needs to hire someone, for example. And then what I want to see is I'm going to throw you in a room and you have individual motivations. You don't know what the objective, you might have your own objective. You don't know what the scenario objective is. And then there's an observer that's, does Ramon give Jan the job? Might be, or it could be like any number of things we might look for, and we see, can they navigate through these type of scenarios? And then we can do other things with interacting with the world environment as well too. And this allows us to check like a certain amount of planning and natural dialogue and interactions in groups and interaction. And they might need to manipulate the world in some way to achieve that thing, but also it's usually a multi-agent kind of coordination plan. And interestingly, then we'll also look at personalities. So for example, like, if what we're trying to do, maybe the test is actually when we say that if I'm trying to create a character that is kind, I might use this as a test and be like, if I assign Ramon as a kind character, then he will give Jan the job. But if I assign Ramon the personality of being an unkind character, then the test passing is Ramon's, no, I'm not going to give you the job. Why would I give you the job? And so we look for even then, like, essentially from our character, like when you think of creating a character, an AI agent as a character, it has a number of different dimensions, almost like a character sheet from an RPG. Do those dimensions actually show up in emergent behavior, yes or no? And we can test these in that way. And then there's all sorts of permutations of this. And so it allows us to do basic things of, can they pivot, can they navigate, things like that we could always do. But we then look at these kind of like more emergent behavior scenarios, and it lets us like know, for example, we could test if we made changes and be like, nobody can lie anymore. Why is that true? We want to be able to detect for that.
That makes me think that maybe it's easier to like have agents test this type, like free games where freeform input play a role. It's not that it's easier, but it's more natural for them to test, because then it's easier for them to just write down what they want to see and see if it happens or not. I feel, funny enough, it seems to me that the closer you are trying to test something physical or a physical simulation, the harder that becomes. And the closer it's something that is like in the LM territory, which is like generating tokens, the easier it gets. Is that?
It depends, right? Because the thing is, for exploratory stuff, 100%, right? But the problem, or the big thing that we're usually also seeing, is that people just want to have like a core suite of regression tests that they want to run. Like usually
this is what
and then that stuff just gets thinner and thinner because there's actually less and less core gameplay, which is shared across like every playthrough essentially for every user. So I think it's just a different kind of testing and a different kind of game that will like emerge from this.
Even from what we do, like I would still say we have a set of what we call like our basic smoke tests that are like, look, these are a set of core functionalities that should always work and we should always see these. And if they aren't working, then in some way the game is fundamentally broken. And yes, to some degree, those are the type that if I can script them, I will script them. But even when you think you've got pretty good automated testing, whether it's like in Unreal, you've got like gauntlet tests or something, you will still usually have humans validate all of these things because it's been so hard to just really know. And to your point, you rarely will you use stuff like Unreal Gauntlet. I would love to know someone who does it, that do visual validation of things, because they won't catch that, yeah, everything worked, but for some reason this text is completely upside down, and they just wouldn't know. And so you always have humans in the loop for those type, like traditionally we have humans in the loop for those.
Yeah, it makes sense. It's, I think usually customers are surprised. It's a learning curve, right? Like the thing is, our tool is so different from what you've seen out there, especially also with automated QA, that customers usually need to learn or experience them. The easiest way we always do is just like, the cool thing about the solution, especially for like simpler games or mostly also for mobile, is we can just do black box, right? Like you can literally just give us a build and we'll just run a test for you. And that's usually where the aha moment is of, okay, I see how this is. It's very interesting. It's usually quite different because people have a bias on like how automated or how QA automation was previously done in games, which in most of cases it's just not really being done or like successful.
But go into the QA providing the fun side a bit. And again, I'm not saying you're saying you can fully replace QA, all my QA people or someone's QA. I know that's true. But it was interesting that Altus also, what the playtest lead that we hired, Lauren, essentially also has informally established one of our benchmarks, which is like the Lauren's vibe check, which is like the, as we switch models, like even if, let's just say we're doing dialogue generation, it'd be like that model gets a 4 out of 5 on the Lauren vibe, and this one gets a 5 out of 5. And like why? Because Lauren's looked at this thing so many times. It's kind of like, it's just more interesting dialogue with that model, whatever, right? And not to say that there aren't ways that we could formalize that more, even as humans, we could probably formalize that system more, but it is a data set that I get because I have a human there in the loop. And I know you've stated there's that, but it's interesting to see like where or how those things overlap. Because Ramon, you had been like, maybe it's even easier, but to some degree, I don't know if I would get the vibe check from those tools.
If you are returning text, then the vibe check is hard, I think.
Honestly, so we vibe check our agents all the time, right? Everyone's looking at runs of our customer, and it's hilarious. Like, favorite part of the job is just to look at the AI play, right? Because oh my god, there's so many funny scenarios.
Have
and
you thought of putting that? Do you have a customer or a game that you've put that on Twitch?
So most of our customers that we're working with either are obviously sensitive about their data or it's an unreleased game. One thing we did at the very start was we played Pokemon with our AI agent. And what we also did now is we played Among Us, which is hilarious. But we didn't put this on YouTube anywhere yet because it's we should, to be honest. It's hilarious. Like, we're a fully technical team, so marketing isn't really the strength. I think the Pokemon stuff was also something you wanted to mention, because it kind of exploded with Claude playing Pokemon and then Gemini, and you can check it out on our website. We did the exact same thing 6 months prior, but no one cared because we didn't.
Hey, I saw it.
And we were a bit salty. We did it first. We did it first, but it's something that we're considering as like a marketing stunt. But the good thing is, currently we have enough to do on the customer side, so we don't. But it's something I want to do it.
The reason I would encourage you is it's not just for the marketing for game studios to come in. I think it also opens the conversation for the broader game industry, like players,
Yep.
right? Because I think there's a lot of misinformation out there around what AI can or can't do, what it's good at, what's fun. And I think there's a line to draw here too, because I am interested in still having a job in the future to make games and not, or whatever that evolves to, right? I don't want to, I'm sensitive to the idea of AI putting pressure on the creative industries. But there are applications that we have that are definitely improving and helping how we can make games and the experiences we have. And I think some of these ways to show things can just spark dialogue in the broader industry. Some of them may be fun and hilarious. Some of them might bring good conversations to the forefront. And so I'd love to see some of these type of things being shown. And yeah, I'm sure that in the beginning, you'll have Ramon and I watching your Twitch stream, and I don't know how many others, but hopefully everyone else also listens to Playing with Inference. But yeah, like those type of things could be really interesting to share more broadly. And so I'd love to see that.
Yeah, it's on to do. As soon as we get to hire like a person for marketing, I think that's one of the first things.
You should create a can AI do this.com and then just spam it with all types of like weird things where you put your agent.
We have a lot of funny like automations internally because like in essence, our agent connects to the device on an OS level, right? Which means we can use the entire phone or computer. So what we, for example, have we have an automation where the AI will order us a random Uber Eats menu to our office every Friday. And what we also do internally as a benchmark is we're solving the Wordle every day and the LOLDL, so the league version. So if AI goes onto the browser, it solves the quiz, and then we just see like what happened. But it's mostly a gimmick, to be honest, at this point. It's very fun.
I do think that, yeah, Ramon, your idea is great. Something like that would be interesting because, for example, it wasn't that long ago when papers that came out saying AI was able to, you know, get to the point of mining diamonds in Minecraft was a noteworthy paper and discussion. And I don't know that, again, I don't know how much is proprietary that you don't want to reveal or something, but to the point that like, I don't know everyone, like things are moving so fast that if you did have that AI is able to mine diamond in Minecraft all the way up to AI wins world at League of Legends, there's some like level of like, how far are we? And so that would be fun. And again, because of the generality of how games imply other things that are possible. But it does bring to your point, I did not expect so much of our conversation today be about AGI, but to that point,
it's closely related.
So this is why, one of the things that I'm very excited about in this space, and I brought up the example of what you're doing with AI in QA and how it mirrors in some other ways of like coding agents even, right? And other, is that one thing that's unusual with this technology is its generalization. And that I think a lot of times when we've made one problem, it's like when I made a database, I didn't accidentally also make a web server, right? But I think sometimes I've not found good examples with this, but it's like sometimes it's like when technology is really changing, we don't always realize that we've solved more than one problem. That it's, oh, when we went from horses to cars, we didn't just solve horses to cars, we solved like other problems. The bad example I've given is it's, oh, I like a customer comes to you and says, I want a way to get from New York to LA faster, and you make an airplane. And they're like, I didn't mean for you to replace boats. Right? But it's, yeah, but that means you go to London too. You don't get from New York to LA on a plane and not also get from LA to New York. And I think there's a generalization issue, like fascination that like, I think a lot of us see it in games. You've seen other companies in there where they're like, they start out making AI agents for games and they realize, oh, I've also solved like X other enterprise problems or business problems. Because both the problems that we face, I agree with you on, in games, are harder and more generalized across a number of spaces. It's an interesting space to do innovation. And then when we solve them both from a model and architecture intelligence space, we're solving intelligence problems that can be applied elsewhere. And I love the kind of Cambrian explosion of people solving the problem and applying it, because we see both divergence and also convergence of solutions across multiple industries, which is just fascinating from an AI industry as a whole.
Why do you think every like foundation model lab or like every AI giant started with the mission to build an AI that can play games? Like OpenAI had this mission, you can look it up on their website. DeepMind had the mission, you can look it up on their website. right? DeepMinds are the OG in the
Yep.
space, but it's a very high bar and a very cool proxy towards a lot of other tasks in the real world.
For everyone in the industry that's interested in AI, they should all be investing in games. That's one takeaway. And two, Nunu is the next DeepMind. Those are my takeaways from my.
Yeah, let's hope both are right. But someone's gonna do it. Shout out to Pim, a friend of mine from General Intuition. They just raised a bunch of money for AI games, right?
Right.
So someone's gonna do it. We'll see who it will be.
Yeah. I think we are at time.
Yeah, we're about there. Yes.
It's been a pleasure to have you. Any other things that we should have asked? Shout outs, things that you want to comment?
Yeah, where people can find you next, either at events or online.
It was a pleasure to be here. Thanks a lot for having me. If anyone listening, or even you two, are interested in looking at state-of-the-art AI agents to play in test games, feel free to reach out to me anytime. I'm always happy to chat to anyone that's in the space.
I'll definitely take you on that.
Yes. Yeah, we definitely have some follow-ups. It's been great. It was great to bump into you at Tech Week recently too, here in the US, and I hope we do that again soon and get some real time.
It'll be a game speed.
Yeah.
All right. Thank you, everybody.
Thanks for listening to the full episode. We really hope you enjoyed the discussion. It would help us out a ton if you subscribe to the show on your platform of choice, as well as shared it with folks you think would find it useful. You can always check out playingwithinference.com to get in contact with us, join our Discord, or just find the links to the episodes. See you next week.